Hypotenuse, yes, and opposite side. So which of the three do we use? Saw, ka, toa? Which one? Ka? Saw, because we are using opposite and hypotenuse. Yeah. So sine 47 equals opposite over hypotenuse. And we need to find the missing side, so we'll take 85 by multiplying it to the left. In this case, an angle is involved. Which sides are we using? Which side is this? Opposite or adjacent? Which side is this? Adjacent. We said next to. Next to the angle. So, and this is hypotenuse. So A and H are used. So which one do we use? There's no such thing as sa. It's so or ka. Sa. It's ka, eh? So cos of the angle equals x over 45. So we'll, in order for us to find x, we'll take the 45, multiply it to the other side. Right? Here's another example. Angle is involved. Which sides are we using? O and A. Agree? Opposite side, adjacent O and A. So which of the three do we use? Toa. 10 of the angle is 27 over x. Now this type is tricky because you see x is in the denominator. Eh? So somehow we'll need to move it to the numerator. What can we do? Yeah, we can multiply it to this. X times tangent of 72. And then we'll remove tangent of 72 by dividing it to the other side. Or we can do this. Tangent 72 equals 27 over x. This is over 1, eh? So what can we do here? We can just flip the two sides over. So that means 1 over tangent of 72 equals. So to find x, we'll move the 27 to the other side, multiply it to the other side. So what do we get? X equals 27 over, which is the same as this. So you can either move the x to the left and then remove the tangent of 72, or do the reciprocal on both sides. Here, which sides are we using? Opposite side and hypotenuse, yeah? So it's so. Here we do not know what the angle is, so sine of x equals 6 over 11. So if I move the sine function to the other side, we can do this. We can do sine x equals 6 over 11. And what is 6 over 11 equal to? 0.3 decimal? 3 decimal. 4. So x will be sine inverse, eh? One decimal place, I've got 33.1. Check, 33.1. Make sure your calculator mode is in degrees. Now the other option you can do is this. 6/11. You don't need to divide this to give you decimal. You can just do this. X equals sine inverse bracket 6 divided by 11. Do this in your calculator. Sine inverse bracket 6/11. Same, eh? But the value you get out of this is more accurate than this. Why? Because you rounded it off here. Here, there was no need for you to round it off. I prefer you do this. Because in the practical sense, we need the values to be exact as they can be. So I prefer that you use this. X equals sine inverse 6/11. So, this example, which two sides are we using? Example B? A and H. So, which we're using car? Cos of x equals 19/27. Can we use the second option? Take the cos to the other side. So, cos inverse bracket 19/27. Cos inverse bracket 19/27. What do you get? 45 points? Listen. If in the example test, if the number of decimal places are not specified, we always recommend that you give your answer correctly 2 decimal places. So if you use the 0.7037, what is this equal to 2 decimal places? 45.28. But if you use this, you get the same value. Okay. Which sides are we using, for example, C? Adjacent, opposite. So, tall. Use the second option, tan inverse, bracket 16/21. 37.3? Yes. 2 decimal places? 0. Okay. Yesterday we did question, okay, let's decide whether we use Pythagoras theorem or SOHCAHTOA for each question. Again, we said if the question does not involve any angle, we use Pythagoras. If the question involves an angle, we use SOHCAHTOA. Okay, question 1. Do we use Pythagoras or SOHCAHTOA? SOHCAHTOA, because an angle is involved. Question 2. SOHCAHTOA and angle. Question 3. Pythagoras, no angle is used. Question 4. SOHCAHTOA. Question 5. You sure? Question 6. SOHCAHTOA or Pythagoras? Question 7. And question 8. Yesterday we did questions 3 and 7, eh? Yes. So let's do question 1. No, I think we did question 1 yesterday. Yes. Question. Wait. Question 4. Let's do question 4 and question 6. Question 4, question 6, and question 8, yes. 4, 6, 8. Question 4. Which sides are we using for question 4? Which sides are we using for question 4? O and A. So Tor, that means tangent is the angle given? Yes. What is it? 72 equals, what's the opposite side? X over 120. So, solve for X. We'll move the 120 to the left. Multiply to the left. X equals 120 times. That is X equal to, correct to 2 decimal places. What is it? 369.32. What's the unit? Centimeters. Do question 6. Go on. Try out question 6. Okay. I need to work. start saying with what now is correctly errors. Adjacent side. What was it? Yesterday in the lecture. What does adjacent mean? What was the meaning of adjacent we discussed yesterday? Next step. We use opposite and hypotenuse. So we use over hinge. What does saw refer to? Sine. Sine of the angle, what's the sine of it? Is the angle given? Yes. Yeah, the angle is given. Okay. Just walking across, I'm still seeing people having problems with labeling the sides. I thought we had tackled that yesterday. We discussed that yesterday. So I'm not sure whether you didn't understand what I was explaining yesterday or you were missing from the lecture yesterday. One of the two. So, We are working according to the angle, eh? So if this is the angle we're using, this will be the, which side is this? Opposite side. And this will be the hypotenuse. I said hypotenuse is always opposite the 90-degree angle, and it's usually the longest side of the three. So according to our labelings, we are using O and H, so. And what does so mean? Sine of the angle, sine of theta. Do we know the angle? Yes, it's given. Over, is it the opposite? What's the opposite side? 75 over the hypotenuse, x. So there were two possible steps I suggested we use. We can either move the x to the other side, or we can invert both sides. Shall we invert both sides? So that means 1 over is equal to x over, then we'll move the 75 to the other side. We'll multiply the across. So x equals 75 over, what's x equal to? Two decimal places. 80? 84.94. What's the unit use? Let's do number 5. Let's do number 5. Again, this is the angle. So label these two sides correctly. Yeah, I need everyone to solve this. Hey, don't create your own version of soccer. Okay. Question 5. Yeah. It involves an angle. So we'll use soccer toy. Which side is this? Adjacent. This is opposite. We are basing this from the position of the angle. So that means O and A. So we're using. Yeah. And Tom says tangent of the angle. What's the angle? X is into opposite over adjacent. You can find the value of this angle, or as I had suggested, just take the tangent. Tan inverse. Just 55.38 degrees. Agree, disagree, don't know. Yes? Round it off correctly. Let's just discuss question 9. Which sides are you using for question 9? Question 9, which sides are we using? Adjacent and hypotenuse, A and H. So what are we using? Chi. Cos of 40 equals adjacent over hypotenuse. Then we can. Question 10, which sides are we using? Which side is opposite? 8.9 and adjacent is 7.2. So we'll use TOR. Okay? So the decision we've made yesterday and today is whenever a problem involves a right angle triangle, we use either Pythagoras theorem or Socrates. How do you know when to use Pythagoras theorem? When the angle is not involved. When angle is involved, then you use either Socrates. And it's important that you label the signs correctly. I've seen that some of you are struggling with them. So get it. What happens if the triangle is not right angle triangle? We will use two rules. One is the sine rule, the other is the cosine rule. Now before we discuss the sine rule and cosine rule, this is what we will all do as a standard course. What we will do is we will label angles using capital letters. I can see an error here. We label the angles using capital letters, and this is how we label the sides. If this is angle B, what's this? The side opposite, we label it as small b. If this is the angle C, The opposite side is side C. This is supposed to be side A. If you have that error in your course book, check. Do you have A or B? B. Correct it. Type O. If this is side T, TUV, if this is side TUV capital, then this will be side small t, small u, small v. Eh? So let's establish that as the standard for all calculations involving non-right angle triangle from now onwards. And this is what that means. Capital letters to label the angles, small letters to label the sides. And a side opposite to the angle. Man, this is. Change this, please. A side is opposite its angle. For example, side A is opposite angle A. Is this an error in your course book as well? Yes. Change this to A. All right, sine rule suggests, this is what the sine rule says. Sine of angle A divided by side A equals sine of angle B divided by side B equals sine of angle C divided by side C. Now, that rule is usually given in the test and exam. So it's a matter of how to apply it. There's a longer proving for this. I don't want to dwell too much on the proving. But if we invert this, we still retain the sine rule. Now, this version of the sine rule is used for certain types of question. The inverted version is also used for different type of question. So this is the proof for the sine rule. Again, I don't want to dwell too much on it. Here, if I invert it, A over sine A equals B over sine B equals C over sine C. When do we use this version? It's explained here. The first equation when we want to find a missing angle. This version is when we want to find the value of the missing side. It's easy for us to decide when to use which one. Now, I don't want you to dwell only on A, B, and C. We can label the angles anyhow. Yeah, we're using P, Q, R. So if this is angle P, where's side P? 72. If this is angle Q, where's side Q? Bottom one. This is side R. Sorry, angle R, where's the side R? Which side are we asked to calculate? PQ. According to our labelings, which side is it? Where's PQ? PQ. What side is that according to the labels that we've allocated? We are using angles P, Q, and R. Yeah, agree? So we are asked to find this length. Which side is this according to the label? We said this is angle P, side P. Agree? Yes. Angle Q, side Q. Angle R, side R. So side PQ is in actual fact side R. Because we are asked to find missing side, then we will use, which version shall we use? This version. Second version. So we will not be using ABC, we will be using PQR. There? Okay. What's it? P over sine P equals over sine Q equals sine R. Do we know the value of side P? What is side P? Do we know? Okay, this is P. Yeah. 72 angle P 52 equals side Q. Do we know it? No, so angle Q. Do we know it? No. R. That's the side we have to calculate. Angle R. So it looks like this is useless. So we can just remove this and equate this two. Yeah? And then we'll just rearrange to solve for R. How do we do that? We take the sine of 27 to the multiplied across. So this is what we have now. Because Q over Q, side Q and angle Q are unknown, even though we can still calculate angle Q, eh? Because the sum of the interior angles is 180. But there's no need for us to do that. We've removed the Q's. There. Take sine 27 to the other side. We've multiplied to the other side. Calculator, do this. 72 sine 27 divided by 7. If you have a calculator, I want you to do that. What do you do? 40? 41.43. 48. Two decimal. 41.4. Here's another problem, another example. We're using angles KLM. So we need to label the sides correctly. Which side is this? L. Which side is? K. This side is? M. Looks like these two are not known, so we can remove them. But because we are asked to find the angle, we will use the first version. But replace A, B, and C with K, L, M. First version, sine K over K, sine M. Do you know the value of angle K? That's what we have to find, eh? Small k,
61.
L and L. Or sine L is 95 over small l.
75.
Do we know this too? No. Remove them. Oh, what is this symbol? That's a Greek alphabet, eh? That is So in order for us to find the value of alpha, we'll take the 61 to the other side. We'll multiply it. Calculate somebody. Think it's 0 point something. 3 decimal. What? 3 decimal places. 810. So alpha. Sine inverse. 50.
54.11.
1. 54.11. Check. Now, if it is up to me, I don't like what we've done here. Because we rounded this off here. Eh? So what I can do here, I can take the sine function across straight away. Alpha equals sine inverse, bracket, 61 sine 95 over 75. Can you do this with me? Calculator. Sine inverse, bracket. 61 sine 95 over 75. Same? Should get the same answer. But for me, this is better because if we have to run it up to 4 or 5 decimal places, this is more accurate. Did you use the fraction function here or division? If you use fraction function, did you get the same answer? I'm hoping you use the division because all of this divided by. But we'll discuss this more in the tutorial. So what have we done today? We've discussed the use of SOHCAHTOA. And again, I've highlighted